In this video, we will be looking at transformers and how to approach problems involving transformers that need to be solved in physics. Transformers are most commonly used for increasing low AC voltage at high current or decreasing high AC voltage at low current in electrical powered applications. The transformer itself is a passive electrical device that transfers electrical energy from one electrical circuit to another or to multiple circuits. The AC current from the primary coil will move quickly back and forth across a secondary coil. This moving magnetic field is caused by the change in a magnetic flux. This will induce a current in the secondary field. And by looking at the voltage of the primary coil, the secondary coil, the number of turns that each coil makes, we can do various calculations. So just kind of how a transformer works. The AC, which comes from your household outlets, usually has a voltage of around 120 volts. But the voltage of the power lines outside your house is much higher. So before entering your house, the electricity from the power lines passes through a transformer, and this device can increase or decrease the voltage which exists between those 2 points. And if you look, you have seen transformers outside of your house. They make the voltage in your outlets of your house safer. Occasionally you'll have lightning strike that may take out a transformer, and it'll send a power surge to your house, knocking out the electricity for a period of time until that transformer has been replaced. Now, as you approach your transformer problems, and I believe I've got 7 of those on your homework assignment, this is going to be the main formula that you use. So let's talk about this for just a moment. Our change in V2 is the potential difference of the secondary. The change in V1 is going to be the potential difference of the primary. Now both of these will be in units of volts. And so typically the problem talks about there being a power line carrying electricity at a high potential difference, and then there's a step down. And so what they'll talk about is this is the primary's potential difference, and here is the potential difference of the secondary. When we get to our N2 and our N1, these are, N1 is the primary number of turns, and N2 is the secondary number of turns. And when we look at solving for these, this will just be a number of turns. There's not any specific unit that you would use for these. You would just put down this many turns. So let's look at an example and see how we would approach this problem. So on this problem, we have a power line carrying electricity at a high potential difference, which is then stepped down. The potential difference of 220 volts. Now this 220 volts is going to be our change in V2. That's our potential difference of our secondary. If the transformer that does this has a primary with 1.5 times 10 to the 5th turns, there's our N1, and a secondary with 250 turns, and there's our N2. What is the potential difference across the primary? Right here. So we're going to use our formula. We're going to plug in, and you could cross multiply and solve for x. You could rearrange the formula. I plugged in my numbers, and I was able to solve for my potential difference for my primary. Again, my units are going to be in volts. So the primary should have 130 kilovolts for the step down. And if you wanted to leave that in volts, I would be fine with that. So this is going to be the formula that you will be using on your homework assignments. You will just be rearranging it. Now, occasionally, the transformer problems might bring in power, and if it begins talking about power, I would remind you that you may have to go back and pull one of your old power equations, such as power equals voltage times current. And then once you are able to solve for, say, that current or that voltage, then if it's asking you to, again, solve for a potential difference, you could plug in the needed information.